All right, so we are going to look at a couple of examples, and for any of these limits, whenever you are doing the limits in these sections, you need the graph, and so it's very important that we make sure that we graph these. So let's do this. So for the first one, we are looking at the limit as x goes to 0 of the function 2x plus 1 over x, and then we're going to look at the right and behavior limit as x goes to infinity. So I'm just going to type my fraction bar first. Just so I get into the habit, we want to do y equals. You don't have to, but it's just mathematically nice. 2x plus 1 over x. And let me hit the home button again. Okay. All right. So we're not, so the idea, remember that at a point, if the limit exists from the left and from the right, it has to be doing the same thing. So as I look at as I approach 0 from the left, this graph is dropping downward toward negative infinity. As I approach 0 from the right, the graph is going upwards towards positive infinity. Those are doing different things, and so this is a limit that does not exist. So number one is D and E. Let's look at the right end behavior. So the limit as we go out to positive infinity. So the idea here, and you can do this really well with demos, is start looking, and you can just really scroll, and as we go, oh, look at what's happening there. It looks like this graph is leveling off at a specific number, and let's see what number that is. It's 2. So this line right here is the line at 2, and so this graph is leveling off at 2. So as x goes far, the answer you want to do is not an x value, but a y value. What is y doing? And so then I would say that the limit as x goes to infinity of 2x plus 1 over x is 2. So the right end behavior, and that would be a horizontal asymptote. It's leveling off at 2. All right, so then let's go, oops, that's not what I want. Let's go up from the bottom and type in our next graph. I'm just going to modify, since I already have a fraction, change this to negative 3x plus 1 over x minus 2. A lot of these functions will have asymptotes. And now let's close this. Okay, so alrighty here. So it looks like at 0, I am at negative 0.5, and the graph passes smoothly through it, no tricks. So then this is negative, my washing machine and my air just stopped at one time. It's very quiet now. Okay, negative 0.5. All right, awesome. Okay, so then the next question says we're going to look at the limit as x goes to negative infinity. So we want to look at the left of this graph. So as I zoom out, we have really two options here. This graph is growing kind of slowly, so it might level off at a number, or it might keep dropping. So let's do a little zooming and see here. And it looks like it doesn't keep dropping downwards. It actually levels off. And I believe that was, if we look here where it levels off, it looks like it levels off at 3, because we have, that's 5 and the 2 lines. Yeah, that definitely levels off at 3. So then the limit as we go to negative infinity, notice I scroll to the left and notice the numbers on the x-axis are negative, would be 3. If you feel like you're starting to get the hang of this, I would encourage you to, if you don't want to listen through the video, check the answer key and see how you did. And then if you want, you can skip to any different point and check these answers. Okay, next one. Let's do 1 over x squared. 1 over x squared. Ooh, okay. All right, this one's fun. So first, what I noticed, we've got a vertical asymptote because that graph at 0 is going straight up to infinity. But the interesting thing is it's doing the same thing from the left and from the right. From the left and from the right, this graph is going toward positive infinity. And so it's not the same numerical value, but it is the same trend. So we would say that the limit as x goes to 0 of 1 over x squared is positive infinity. And then as I look at as the limit as x goes to infinity, it's going to the right, and it is leveling off at 0. It's heading straight towards that x-axis, and so this limit would be 0. All right, awesome. Next up. Let's Yeah, this one looks good. Let me put my fraction bar in first. 2x squared minus 5. Oops, that's not minus 5. Hold on. Minus 5 over 3x cubed plus 2x. Okay. Alrighty, so again, as we notice here, hopefully you're starting to pick up. Now you see, all right, this graph this time is going toward an asymptote, but the two graphs are splitting. They're going two different directions, on the left toward positive infinity, from the right toward negative infinity. And so if they're going different directions, the limit does not exist. Different numbers, different trends. So this would be D and E. But as we go to positive infinity, looks like we briefly jump above 0 and then it levels back down. And as we keep going out, we're getting closer and closer and closer to 0. And remember, with asymptotes, we don't touch them, but we do get close. And limits are a really awesome way to describe that happening. So this limit is going toward 0. Okay, I'm going to skip that one, and I'm going to go on number 5. For number 5, if you want to try this out and then check it, I'm going to give you the answers. So if you want to pause it right now, I'm about to write the answers. So for number 5, the limit is -1. For the second part, it's asking the end behavior on the left toward negative infinity, and this graph is trending also toward negative infinity. Okay, next up, we're going to do one that's more complicated. So that whole thing in parentheses, e to the x times sine of 2 pi x. That's the whole function. So let's get that inputted. For the e function, I'm pretty positive that what we want to do, I'm just doing a quick check. Yeah. So what we want to do is we can actually just use the E letter under the alphabet page. And look, it's got it sorted, it knows its value. And then we're going to raise that with the button to the x power. And then times, under trig, grab the sine function, 2 pi, pi is right on the bottom of that little place there, 2 pi x. And whoo! There we go. Okay. Oh, this is a cool graph. Man, I love cool graphs. All right. So here's what we got. This is a oscillating graph. As we look at 0, we can zoom in nice and close and we can see this trend here. So as we zoom in at 0, this is going straight through 0, so the limit would be 0. And then now, we've got an oscillating function, and generally when we look at the end behavior of functions that grow and oscillate into they grow into like a bigger V, it's not going to exist. And so that is the case here. This one is growing crazy rapidly. This is really cool. I'm just going to stretch this out so we can see this. And it's growing really rapidly, and it's just bouncing back and forth between one negative number and then a bigger positive number and a bigger negative number. And so this is going to diverge, meaning it's not heading towards the same number, so the limit does not exist. If you can't tell, I get excited about cool graphs. So here we go. Next one. We're going to look at a few more of the kind of different ones, and then we will go from there. So we have 2 to the x power plus x. This one is not super exciting. It's not quite as cool as the last one. As we zoom in at 0, we can see it stretches out a lot. At 0, since it passes through smoothly, we can just pick the y-intercept value of that point, and that would be 1. And then the end behavior as we go to negative infinity, this graph, you can see it's dropping down, and it's going to keep growing more negative as we go. And so this is going to negative infinity. Sine of 1 over x, there is a high likelihood that that will be an oscillating function. Let's see what we get. So sine of 1 over x. And again, as you zoom, it does crazy stuff. It's hard to see. The home button is a great tool for us here. All right, looks like we do have an oscillating function. Let's zoom in nice and close and see what's happening. Oh, this is an interesting one. So as we look here, as we zoom in at 0. We can get in even closer. I'm stretching this out so that we can try to see it. It is oscillating as we get closer and closer to 0. Look at right now, I'm at 0.02. This is like crazy close zoomed in. It's the Y values are not getting any closer to 1 or to 0. They are just bouncing back and forth between 1 and -1. Every single time we're going to 1, -1, 1, -1, 1, -1. So it's not converging toward a smaller number, it's just going back and forth between the same two numbers. So this would be a case where this oscillating function at the point 0 does not exist. Then, as we zoom out, the graph kind of goes crazy, or it actually stops going crazy, it starts leveling out. And as I look at positive infinity, it goes up, but then if we look outwards, it starts heading back down toward 0. And so then this limit, as I go out really far, is going to 0. Okay, we are going to skip e to the 2x. So if, again, you want to pause it, now would be a great time. For number 9, the answer is 1. And then as we go to 0, as we go to negative infinity, it is going to 0. It's horizontal asymptote. All right, and lastly, this is a good one. We have cosine of 2 pi x. Again, you want to make sure you're in radian mode for all of these. And we've got ourselves a beautiful sine curve. And if we hit that home button, we get this beautiful wave. And as we look at 0, it is smoothly passing through that point, no tricks here, and it is up at 1. And so our limit as x goes to 0 of the cosine of 2 pi x is 1. And then let's go out to positive infinity. What is happening? As I go to positive infinity, our function is oscillating between any number somewhere between -1 and 1. We're waving back and forth. So as I go out further, I am not heading toward any one specific value. If I was at some point at positive infinity, I could be at +1. If I go just a little bit further, I'd be at -1. And so there's no specific trend, one number that it's converging towards. And so this is an oscillating function. Even though it's not doing anything crazy, it is oscillating. So this limit does not exist. All right, that is it. So you've got your own practice set for this section. I hope this was helpful to you. And then once you finish that practice set, please make sure to go on to 12.1 day 3. Both those assignments will be due on the next time we meet, which is either going to be, sorry, I got the new schedule mixed up. That will either be Monday if you're an odd class or Tuesday if you're an even class. Alrighty, have an awesome weekend.